So today we will be discussing the programming which is 8085, which is we will be discussing three programs. The first one is for the program for adding the even numbers. Second one is the finding the even number from a given list. And third one is to count the negative numbers, zero number or the positive number in the given list. So first of all, we will be discussing the program which is going to uh, calculate the sum of the even numbers from the given list of the numbers. And as far as the total numbers which are present, it is available at 2200. 2200 लोकेशन पे कितने नंबर्स हैं वो दिया हुआ है and the series of the number is starting from memory location 2201. And whenever we have to add all the even numbers, so it is possible that whenever we are going to add the multiple even numbers, so the result may be more than 8 bits. So we are storing the result in the form of a 16-bit. And so we are storing the number in the form of 16-bit means we have to save the sum and the carry. So it means 2 memory locations will be required to store the sum. So 2200 is the memory location where the number of how many numbers are available, out of which you have to test that how many even numbers are there, and you have to add all these even numbers. These even numbers are available, the numbers are available from 2201, and you have to store the result at 2300 and 2301. So how we will be going to do this? So first of all, we have to initialize the sum counter, because whenever we are finding the even numbers, and so we have to take the sum of all the even numbers. So we have to initialize a register which will be working as a sum register. We have to also initialize the counter, because how many numbers you have to test to find out the even number. And then you have to initialize the memory pointer also, because you must know the location of the memory from where you will be able to get the data. So once the initialization process is done, we will try to find out that the first number, whether that number is an even number or not. If it is an even number, then what we will do, we have initialized the sum register. We will add that sum register initial sum with the value which is the even number, and the sum will be updated. Then we are also going to check whether these two sum is going to create a carry or not. If it is going to create a carry, then carry will be updated. Carry register, we will be using a register which will be used to store the carry. So carry will be updated. But if carry is not generated, so we will not update the carry. If the number is not even, we have not to add. So if the condition is no, in all these two no cases, it will jump to the place where it is going to increment the pointer and decrement the counter, and then you will checking that whether the counter has become zero or not. If it is not zero, we will execute the loop. Otherwise, it will if the counter becomes zero, then we will store the result and end the program. So the basic purpose, the basic theme of this program is to check the number, whether the number is an even number or not. If it is even number, we will add. After adding, we will check whether there is a carry or not. If there is a carry, carry will be updated. And if both the conditions are not true, we are going to check the next number and counter will be decremented. So in this way, this program will go on. Now at 2200, there are 4 numbers. So 2200 is loaded with 4. The first number is available at 9A. Next number 2202, it is available, and this location we have 52, 89, and 3F. Out of these 4 numbers, 2 numbers are even number, and these 2 numbers are added together to get the result EC, and this EC will be stored at 20, and no carry is generated, so carry bit remains 0. So how you will be able to find that the number which has been fetched is an even number or not. This is very clearly visible by checking the D0 bit, because D0 bit is having the weight 1. So if that bit is 1, D0 bit, least significant bit is 1, it means that number is an odd number. Otherwise, the number will be an even number. So for checking this, whether the number is an even number, what we have to do, we have to do certain AND operations so that it will be going to check whether D0 bit is 1 or 0. If it is 0, it is an even number. If it is 1, it will be an odd number. So let us see how the program works. So first of all, the number of count is being loaded into the accumulator, and the count value is available at 2200. Since it is 4, so accumulator will be loaded with 4, and we will put this value into a C register. So C register will be working as a counter. Then we will initialize the HL pair register by the memory pointer, which is 2201. And then we will initialize the sum value as well as carry value. E is used as a sum register and D is used as a carry register, and both these registers are initialized in the very beginning. So first of all, we will take the first number into the accumulator. That is the 2201 content. It is loaded into the accumulator. Once it is loaded into the accumulator, we are going to check, because we have to check whether this number is an even number or an odd number. We are going to check this number by using a logical operation, AND operation with 0, 1. Now what this property of AND operation is, if both bits are same, 1, then only the output will be 1. Otherwise, in the rest of the cases, the output will be 0. So when we are doing this AND operation with 0, 1, 0, 1 means 0, 0, 0, 0 and 0, 0, 0, 1. If the number which is available in the accumulator is odd number, when it is odd number, so the D0 bit of the accumulator will be 1, and D0 bit of this number which is ANDed is also 1. If both the bits are 1, it means 0 flag will not set. Otherwise, if D0 bit of the accumulator is 0, it means it is a positive number. Then in that case, the content of the accumulator will become 0. And when the content of accumulator will become 0, it indicates that the number is a positive number. Even number. Otherwise, if 0 flag is not set, otherwise it will show that the number is not a even number, but it is a odd number. So whenever we are going to do AND operation with 0, 1, and 0 flag is not going to set, if 0 flag is not going to set, it means it is an odd number. So if it is odd number, we have to not to add that number. But if 0 flag is set, then instead of going to skip, it will move to the next. What is the next? What it is going to do, it is copying the sum, initialized sum register into the accumulator, and then it is going to add the number, which is an even number, which is tested over here with the content of sum. So sum is equal to sum plus data. And this accumulator content will contain the sum value. So we will store the sum back to the E register. And we will check whether there is carry generated or not. If carry is not generated, we will skip. If carry is generated, we will increment the content of carry register, which is D, by 1. So if 0 flag is not set, or even it is going to skip, and whenever it is skipping, it is going to increment the pointer, it is going to decrement the counter, and till the counter becomes 0, it will go back. It will go back, it will test the second number. We will test the number whether it is an even number or an odd number by doing AND operation with 0, 1. If 0 flag is not set, it means the number is an odd number, we will skip. But if the number is an even number, we will take the previous sum into the accumulator and then going to add the new even number. And then after doing that, we will restore the sum which is available in the accumulator into E and check whether the carry is generated or not. And this process will go on till we are going to decrement the C, and when C will become 0, what will happen? E register will contain the sum and D register will contain the carry. So E register will be copied into A, and this accumulator content will be stored at 2300, and D register is copied into A, and then the content of carry register will be stored in 2301. So in this way, you are by doing this ANI 01, you are able to test and find whether the number is a negative number or it is a even number or it is an odd number. If it is an odd number, the zero flag will not set and it will skip. But if it is an even number, it will zero flag will be set and it will doing this particular process, which is the adding of the even number. So in this way, we are able to do this program. The next program is a write an assembly language program to separate even numbers from a given list of 4 numbers and store them in another list starting with 2200. Assume that the starting address of the 4 number list is 2300. So what here I mean to say that there are 4 numbers which are given and these 4 numbers are available at 2200. And out of these 4 numbers, you have to test whether the number is an even number. If the number you find that it is an even number, you store that number at 2300. So for that, we have drawn a flow chart. We have to initialize the counter because we must know that how many numbers are available. We have to initialize the source pointer because we have to, from where we have to take the data and test whether the number is an even number or not. If it is an even number, we have to store that even number at the new memory location. So you have to initialize memory pointer that is source, and you have also initialize the memory pointer which is a destination. So 3 initialization process has to be done. One is counter, another is source pointer from where you have to read the data and test it. And then once you find that the number is an even number, you are in requirement of putting that number into a certain other memory location, that is the destination pointer. So 3 initialization is to be done. Then we check whether the number which we are going to read from the source is an even number or not. If it is an even number, we will store that number at the destination. But if it is not an even number, we will come and we will check the next number. And for checking the next number, we will increase the pointer by 1 and decrease the counter by 1. And this process will go on till the counter becomes 0. So until the counter is not 0, it will go to the process even one by one. It will first check the first number, it will then check the second number, then it will check the third number. And the time when it is going to receive any number as an even number, it will store that number at the destination. And if the number is not an even number, it will not store at the destination. It will go and try to search for the next number. So in this way, this particular program will be going to work. How the program will work? First of all, I have initialized the memory pointer, source memory pointer from where we are going to get the data. That is LXI 2200. What this will do, LXI H, it should be LXI H, it wrongly written LXI H. We are going to load the HL pair content by 2200, as well as we are going to initialize the memory pointer destination. So LXI D should be here. Here there is some mistake. D is not written. We can write D also. So here it is H. So HL pair is working as a memory pointer and D pair is working as a destination pointer. And we are using C register for the counter, that how many numbers are there. So first of all, we will get the number and we'll copy it into the accumulator. And then we will apply the same logic which we have applied in the last program. By doing ANI 01, we are able to test whether the number is even number or the odd number. If the number is an odd number, zero flag will be set. But if the number is an even number, the zero flag will be set. If the number is an odd number, the D0 bit of that accumulator content will be 1. So zero flag will not set. And if zero flag is not set, it means it is an odd number. If we have not to store that number, we will skip. And skip, after skipping, what it will do, it will increment the pointer, it will decrement the counter, and it will go back. But if the number is an even number, so in that case, it will not jump because zero flag is set. So zero flag is set, so what it will do, it will use the instruction STAXD. What this instruction will do, it will copy the content of accumulator to the memory location, which is pointed by DE pair register, and DE pair register is pointed with 2300. So the first even number which we will be getting, it will be stored at a memory location 2300, and then we will increment the destination pointer INXD by 1, and then we will increment the memory pointer source, decrement the counter, and this process will go on and on until all the numbers which is not being tested. So whenever we find any even number, we will store that number. But if we find that it is not an even number, it is an odd number, we are not going to store, we are skipping these two process, and it will go. A list of 10 numbers are stored in the memory starting at 6000. Find numbers, find number of negative, 0, and positive numbers from this list, and store these results in memory location 7000, 7001, and 7002. So what do you have to test? You have given 10 numbers, and these 10 numbers are available in the memory. And memory, where it is located at 6000 onwards. What do you have to do? You have to test whether the number is a negative number, whether the number is a 0 number, or whether the number is a positive number. If you get certain number of negative number, you have to add. What you have to add? You have to count that how many negative numbers are there, how many 0 number are there, how many positive numbers are there. And then once you are able to test all these 10 number, there is a possibility that there are certain negative number, there are certain 0 number, and there are certain positive numbers. So how many negative numbers are there? It has to be stored at 7000. How many 0 numbers you have found? You have to store it 7001. And how many positive number you have found? You have to store it 7002. Suppose out of 10 numbers, there are 3 numbers which are negative. So the result which you have to show at 7000 should be 3. There are 2 numbers which are 0. So 7001 will show 2. And 3 numbers are negative, 2 numbers are 0. So naturally 5 numbers will be the positive number. So 7002 will represent 5. So what you have to do, you have to take the number, you have to test it, whether this is a negative number, whether it is a 0 number, whether it is a positive number, and you have to do the counting process. Once you find any number to be negative, you have to count it. Another number you are going to test, you have to count it. But first you have to detect whether the number is a negative, positive, or 0. And once you are getting, you have to use a counter for counting it. So the flowchart has been drawn for that particular purpose. We are starting and initializing the memory, initialize memory pointer, initialize counter to count the total number. Total number are 10. And we have to initialize the memory pointer because we have to know that from where memory location, from which memory location the data is written. Then we have to initialize the counter for the negative, positive, and the 0 number. For that particular purpose, we have to use 3 different registers, because these 3 different registers, one will be counting negative number, one will be counting 0 number, and another will be counting positive number. So these 3, for this counting, we are in requirement of 3 registers. Now the process will start of getting the number. Is the number is equal to 0? Whether the number is 0, if it is so, we will increment the 0 number counter. If the number is negative, we will increment the, is the number positive? Is the number negative? Yes, we will increment the negative number counter. But if neither this number is a 0 nor it is negative, automatically it proves that it is a positive number. So by incrementing accordingly, with the number which you have getting, whether it is testing it as 0 or testing it as a negative, if it is not found, it is a positive number. But if it is a 0, we will increment 0 counter. If it is negative, we will increment negative counter. If it is positive, we will be incrementing the positive counter. And then we will be, after checking the first number, it is the duty to check the second number, then third number. And this process will go on until the counter is being decremented each time until the counter becomes 0. Once the counter becomes 0, it will stop. Otherwise, it will go back, take the second number, And again, it will be tested whether it is 0, whether it is negative, whether it is positive. And each time, what we have to do, we have to increment depending upon the detection that the number is a 0, positive, or the negative. We have to increment the individual counter depending upon the number. So based on this flowchart, a program is written. The first line of this particular program is to initialize the memory pointer from where you are able to read the data. So 6000 is the memory location where the data is written. So HL pair is loaded with 6000. And then we will be using a certain register which will be working as a counter, that is initialize counter. Since we have 10 numbers, so that is why we have loaded the C register with 0A, which is hexadecimal equivalent to the 10 decimal. Then we are using B register to store the negative number. We are using D register to store the positive number. We are using E register to store the 0 number. Then what we are going to do, first of all, we are copying the number into the accumulator. Once we are able to copy the content of the memory location into the accumulator, first of all, we will check whether the number is 00 or not. And for that, we will be using an instruction, compare immediately with 00. If we are going to compare the accumulator content with 00, and if the accumulator content is 00, 0 flag will be set. If 0 flag is set, it automatically comes to know that the number is 00. So 0 flag will be set, so it will go to the next one. Next one, what it says, it is going to increment the content of E register. And E register is a register which is counting the 0 number. So increment E, because the first number which we have found is 0. So increment E, so it increment the 0 number counter, and then jump to the next 3. Next 3 means first number you have already checked, and now you have not to check whether it is a negative or positive because you have already found it 0. So what it will do, it will jump to the next. And next 3 is what? Increment the pointer, decrement the counter. Now suppose whenever we are doing CPI 00 and the accumulator content is not 0, then what will happen? 0 flag will not set. Then it will have to test whether the number is negative number. Now, negative number can be tested by checking the D7 bit of the accumulator content. Now, the D7 bit of the accumulator content can be checked by using an instruction ANI 80. ANI 80 means the most significant bit of this is 1. And if the number is negative, it means the content of accumulator, the most significant bit of the accumulator will also be 1. And if this is being compared, this is being ANDed with 1, 0, 0, 0, 0, 0. So if it is so, 0 flag will not set. If 0 flag is not set, it means it represents that if 0 flag is not set, it represents that the number is a negative number. And once it finds that it is a negative number, it is jump on no 0, it is going to next 2. The number is negative, so go to next 2. What is next 2? It is going to increment the content of B. And what is the content of B? It is storing the negative number. Now, if 0 flag is not going to set, if 0 flag is going to not set, it means it represents negative number. But if 0 flag is not set in this case, 0 flag is set in this case, it means automatically it means that the number is a positive number. And if the number is a positive number, we will increment the content of D. What is D? It is storing the positive number. So while incrementing the content of D, it will go to the jump next 3. Next 3 is what it says. It means in this particular place, we have already tested whether number is 0, whether the number is negative, whether the number is positive. If the number is negative, it will jump to the next. Sorry, if the number is 0, it will jump to the next one. If the number is negative, it will jump to the next 2. And if the number is positive, it will increment automatically here the D content. And then it will jump to next 3. And what is the next 3? You can check it with this. If the number is 0, increment the 0 number counter. If the number is negative, increment the negative counter. And otherwise, the number will be a positive. And all these 3 cases is going to lead towards the incrementing the pointer. So that is why we are incrementing the pointer, decrementing the counter, and this process will go on till the counter will become 0. And till the counter is not 0, it is going to go back. It will be taking the second number, checking it's 0, whether it is 0 or not. If it is 0, it's okay, it will jump. If it is not 0, it will check for the negative. If it is negative, it will jump. But if it is not negative, not 0, it means automatically it is positive. So that is why for checking the positive, we have not used any instruction. If the number is not 0, if the number is not negative, it means the number is positive. So we are incrementing the positive. And once this process will be over, after decrementing of C, 0 flag, the C content becomes 0. 0 flag will set and it will not go back. So what we have to do, we have to store whatever number count we have done in register B, D, and E. We have to store it at certain place. So first of all, we will initialize the memory pointer by 7,000, copy the content of B register into the memory. So what it will do, all the negative number count will be copied into the 7,000. Then 7,000 is incremented, HL pair is incremented so that HL pair will have 7,001, incrementing the pointer, and then what we are doing, copying the content of E into the memory. So E is storing the 0 number count. So 0 number count will be stored in the memory, that is 7,001. Then HL pair is again incremented so that it will become 7,002. And we are going to copy the positive number count, that is D register, into the memory, and then it is going to end the